Final thing to talk about is representing graphs using matrices. So you can represent a graph with what's called an adjacency matrix, which records just the number of direct links between vertices. If you put values in, it will be called a distance matrix instead. It's not a big deal, but if there's no edge, you just put a dash in, although 0 would be acceptable, I think, as well. Using this graph, we can complete this adjacency matrix. So Bury St Edmunds is directly connected to Sudbury and Stowmarket. So I'm going to put 1 in both of those. Stowmarket is directly connected to Bury St Edmunds and Ipswich. Sudbury is directly connected to Bury St Edmunds, Ipswich, and Colchester. Colchester is directly connected to Sudbury, Ipswich, and Harwich. Harwich is just directly connected to Colchester. And finally, Ipswich is connected to Stowmarket, Sudbury, and Colchester. All the rest of these, they're not connected up, so we can put dashes in all of those. Going backwards, if we're given the adjacency matrix and asked to draw our network, that's what you do. So for this first one, I've got A, and I know that that is directly connected up to B. So just going to draw B down here, and that's it. A is directly connected to B. B is connected to A, which we've got, but it's also connected to C. And it's also connected to E. B in here. Twice, so there's a double connection between B and E. And it's also connected up to F. Does that? C is connected to B, which we've got. It's also connected to D. And it's connected to E, not F. D is connected to C, which we've got, and it's also connected to F. E is connected to B twice, which we've got. It's connected to C, which we've got, and it's also connected to F. And then B is connected to F once, which we've got. D is connected up. E is connected up. F is connected up to itself, though. That's twice. There's those two ends going into that node. Now, so far, notice that these have been symmetrical down the diagonal because this hasn't been a directed graph. But if it is a directed graph, then your matrix will no longer be symmetrical. So for this one, we just have a connection between A and B. Even though there's a line from D, it's going the wrong way. So just put 1 in A to B. Then we've got B is just directly connected to E. The other ones are going the other way. C is just directly connected to B. D is directly connected to A and E. And finally, E isn't connected up to anything because the arrows are going into it, not out. This is the adjacency matrix for this graph. We can finally do this if we have weights on our graph. So very quickly, Bury St Edmunds is 15 miles from Stowmarket, and it's 17 miles from Sudbury, and that's it. Stowmarket is 15 miles from Bury St Edmunds and 12 miles from Ipswich, and that's it. Sudbury is 17 miles away from Bury St Edmunds, 20 miles away from Ipswich, and 15 miles away from Colchester. Colchester is 15 miles away from Sudbury, 17 miles from Ipswich, and 21 miles from Harwich. Harwich is just 21 miles away from Colchester. And then finally, Ipswich is 12 miles from Stowmarket, 20 miles from Sudbury, 17 miles from Colchester.